While memories of Hurricanes Francis, Gaston, and Charlie are fresh, September 18th marks the one-year anniversary of another big storm. That's when Hurricane Isabel slammed into the United States. By all accounts, it was a beast, a Category 5 at one point, though it had weakened substantially by the time it made landfall in North Carolina. But Isabel also provided a rare and remarkable opportunity for researchers at NASA. To a degree never before achieved, orbiting Earth-observing instruments captured data about Hurricane Isabel from its birth to its death. After a year of analysis, experts have new insights into the behavior of these behemoths.
Hurricane formation is essentially universal. We believe we will distill hurricane formation genesis down to a few key processes, small-scale probabilistic processes, but those same processes are going to be operating in any ocean basin, kind of like the rules, the laws of hurricane formation. I think we're going to write that book in the next few years.
If you live in the United States, hurricanes are usually experienced as Atlantic Ocean phenomena. But here's a surprise. Strong evidence suggests that hurricanes start in East Africa. Here in the highlands of Ethiopia, fast-moving air blowing off the Red Sea and the Gulf of Aden gets interrupted by skyscraping peaks.
It's kind of like me putting a stick in the middle of a creek and watching the water slosh over that stick, and then you'll see turbulence downstream. Well, that's what these waves are. These are turbulent eddies, large-scale whirls and disturbances in the atmospheric flow that are being shed off of these mountains.
Those atmospheric disturbances move across the African continent and skid into the warm waters of the tropical Atlantic. If the ocean water is warm enough, and a handful of other conditions satisfied, those ripples gain strength and begin to organize themselves into the traditional spiral of a hurricane. To some extent, the necessary conditions to create a storm are a matter of statistical probability, and questions of how and why those conditions arise are still being explored. But this unprecedented post-mortem of Hurricane Isabel may help scientists take the necessary steps to reveal fundamental truths about the interrelated processes on Earth. It may also help experts keep their eyes on storms like Francis and Charlie, without them sneaking past us by surprise. At the Goddard Space Flight Center, I'm Michael Starobin.